Hey guys, today I will show you how you can create a Flappy Bird like game using the pygame library in Python. So you will be creating a game something like this. Pressing the space, you can directly control the bird how it goes, and we will be adding some pipes through which the bird will pass, and yep, that's it. So let's get started. Now before you start, I have added the GitHub link to this repo. From this GitHub link, you can download these four files that are the assets, the background, the pipe images with which you can animate the whole game. I have also added the code for it. You can directly test it out, but if you want to try it yourself and learn it, then here we go. First, we will start by creating a main Python file. And in this main file only, we will be adding our entire piece of code. Now to start with the code, first we will be adding some few libraries. The first one is going to be obviously pygame. Now if you don't have pygame on your system, then you can simply do that by opening a terminal. Now I'm using VS Code, so you can directly go to the terminal and select new terminal, but you can also just click Windows R key and type in CMD or open your command prompt, and you can just simply type in pip3 install pygame. Hit enter, it should install the library. I have already installed it, so it's just showing me the requirements was already satisfied. Once you have installed it, you can start with the game. The next library is going to be from sys import exit. Now this library will be using to exit our application. Now in a minute I will be explaining to you why do we need it, but for now you can just import it. The next is we'll be importing the random library to create random numbers. Now, when we are creating the game, now in the game, if you see the position of the pipe is not the exactly same, but it randomly changes. It sometimes goes above, it sometimes comes below. So for that, we'll be using random numbers to generate random positions for the pipes. Now I will be also importing the time library to play with the timers a little bit. Now, when initializing a pygame, the first thing you need to do is pygame.init. This will initialize the pygame library. Next, I will be adding a config variable. In this, you will be adding a lot of different configurations, a certain metadata for the bird, how to animate it, certain variables like screen width, screen height, etc. So you can create a config variable. It's not necessary, but it makes life a little bit easier. So first thing that we need to add is screen width. I will be setting it till 800, and the second one is going to be screen height. Now I want the screen height to be 600 to give it a little bit of that rectangle feel. Now right now these are going to be the only config variables that we need to assign. In the coming few minutes, I will be creating other config variables too as we need them. Now, next thing, we need to set up the screen that will be displaying on. Now, pygame uses a screen variable, and that would be basically the data that will be containing the things that are being displayed by pygame. So for that, we'll be creating a screen variable, and for that, the code is just goes pygame dot display dot set mode. Now in this, you need to add in the screen height and the screen width. So you can directly fetch it from the config variable or hard code it. The first one is going to be the screen width, and the second variable is going to be the screen height. Now do remember that we are adding the screen height and the screen width inside a tuple. Now In the game, we also need to add a text that says the name of the game. I'm naming it as Rappy, so you can add whatever the name you want. So to add the title, we type in pygame dot display dot set caption and the name. So I will put in Rappy. The next is we need to define a clock. Now, when we are running the game, when we are playing the game, every computer is different and every processor speed is also different. So the game itself doesn't know what speed to run at. So we need to define that. So we'll be targeting 60 FPS. It's just a simple game. Almost any computer can run it, even if it's 10 years old. You should be good to go. If you feel it's getting lagged, then maybe you can reduce the number a bit, but 60 is going to be fine because that's the thing that would be defined. Because using that speed only, I have calibrated the variables and how the animation works and other stuff. So if you can just stick to 60 FPS. So to define that, first I will be creating a clock. So the clock variable goes as pygame dot time dot clock. Now for the timer of 60 FPS, I would like to wait a few minutes for that too. Now in pygame, we add event loop basically, and in that loop, every loop is going to be a frame and that frame is going to be displayed on the pygame. So for that, we need to create a loop. Now we simply type in while true and whatever our animation goes in, it goes into the game. Now in this while loop, pygame has these events where whatever is happening with the interface, that is your keyboard and mouse and other stuff that's going on, is recorded into it. So when we need to check if something has happened, we need to access that event, and for that, we will be creating a loop inside it which tracks if anything did happen. So it goes as for event in pygame.event.get. Now in this loop, we'll be checking in what the different actions that were performed, and if they were performed, what should we do with the program. So the first action is going to be if event.type, that is the event type, equals pygame.quit. Now this is when the person clicks the cross button of the window. So if that gets clicked, then we need to quit the game. Pygame doesn't know itself that when it has to quit the window, we need to tell it when to. So the next line is pygame.exit. If it gets clicked, pygame.exit. And we will be using this exit function 2 to exit from the code. This just exits from the pygame, but we also need to exit from the code itself. So exit. And after this event loop, once we have checked what we want to do, we mention the timer of a game. So it goes as pygame dot display dot update. Now this function basically updates the frames as it goes through the loops, but we have not added any animation here itself, so it doesn't do anything right now, but it will do a lot afterwards. And after that, we type in clock dot tick, the frame rate of our game. It's going to be 60. Now this is not exactly the frame rate that we want, but it just says that do it this thing that's in the loop 60 times every second. And if it tries to go beyond 60, let's say your processor is too fast and it can do 100, so clock.tick would prevent that and limit it to 60 fps only. At this point, you can start your program, run your program, and it should display a screen. Now right now, the name of the game is coming up that we have set above as the title, but there's really nothing inside. It's just black because we have not added anything to the game. Now we will be adding something and animating a game itself. Now when I click that close button, it exits. It does say some error. It has no attribute exit. Okay, it's not exit, it's quit. So if we run it and close, this action was event type pygame.quit. When we just clicked on the cross button, it invoked this and it enabled the pygame to exit and then exit from the code itself. Now starting with the animation, the first thing we need to add is the background. The game doesn't really look anything good without the background, so we will create a background of our own. Background equals pygame.image.load and the name of the file. Now we will be importing a file that's called bg.png. This is going to be a background. So you, if you didn't download it right now and add it to your folder wherever you are creating your Python file. Type in the name of the file, type in convert underscore alpha. I will let you know what this does in just in a minute. Now we have imported a background image, but we are not actually displaying it on the screen. To display it on the screen, we need to add it in the loop. For that, the code goes as screen.blit background and the position of the image. It's going to be at 0, 0. Now if I run this, okay, it says no video mode has been set. That's because I have actually initialized it before initializing the Pygame window itself, so I will need to initialize it afterwards. Now let me run it again and you can see the background image is getting loaded here. Now do remember the 0, 0 coordinates is this point. If you know a little bit about coordinate geometry, then it's a little bit different from it. It's the fourth quadrant, but the 0, 0 it starts from here, and as you go below, y coordinate becomes positive, and as you go from left to right, x coordinate becomes positive. So it's a little bit different, but that's how it is. Now this point is 0, 0 and the image of the background image is exactly the size of our screen width and screen height, that is 800 by 600, so it gets displayed exactly inside the screen. Now after adding the background, now in the completed game, if you see, then with the background the bird is right there, and with that it gives some instruction that what you have to do to start the game. So it just says press space to start. Now I have added this using text. Now to add some text to your Pygame, what you need to do is first define the font and then define the text itself. So it's a two-step process. Now I will be using a single font for the entire game. It's just two piece of text, but you can use the same font for all the text. But it's always going to be a two-step process. First the font, then the text. Now first to create the font, we will create a variable called text font equals pygame dot font dot capital font with a capital F. Now first we need to define the actual font like Arial, Helvetica, Sans, but I'm just going to stick with the default font, so I will just type in none. So it will just take the default font, whatever it's stored, and type in the font size. So I will be keeping it as 50. Now after creating the font, we need to create the text itself. Now before creating the text, I would like to mention that in Pygame, every object or anything that is there, it always consists of two things. The image itself, that is called the surface. It's not necessary for the surface to be an image, but surface can be anything. It can be text, it can be color, it can be an image or anything. But the actual thing that gets displayed is the surface. And with the surface is a rectangle. Now, what rectangle is basically, it defines the position of the surface itself. Now, when I press space, the surface starts moving. But in the back, I'm actually not moving the surface, but the rectangle associated with it. So you can think it like the surface is the thing you see, and we associate with the rectangle, and the rectangle defines the position of the surface. So right now in the text, we will need to create the two things, the surface and the rectangle. So we first create a surface for the text and we will call it start game text surface, or surf for short, and text font, that is this variable, dot render the actual text. Now we are just saying press space to start. Now this is the first parameter. The second parameter we need to add is whether it does anti-aliasing. Right now I'm just not going into it. It's just used to make the text edges a little bit smoother, but right now I'm just keeping it as false. After this, we need to define the color of the text. So I will just keeping it as red text. And with the text, we need to create the rectangle for it that defines the position. I will just type in start game underscore text rect for short, just to name the variable. And we use start games of text dot get rectangle, and in the rectangle we need to define where we want to keep the position of the surface. Now in pygame, the rectangle is exactly what it is. It's a rectangle, and rectangle has edges. Now it isn't visible in the game itself, but every object has a rectangle around it, and with rectangle has its sides, its midpoints, and we can utilize that positions to define where we want to place that rectangle. So the first position I'm going to use is center, that is the center of the rectangle. The center is going to be config of screen width and screen height, and we need to keep it at center, so it's screen width by 2 and screen height by 2. Now if you run it, it's not going to display anything. So we need to first show the text on the screen. So for that we use screen.blit start game text surf. First is going to be the surface that we want to define, what to show on the screen, and the second parameter is going to be where to define it. And the where to define it, we define it using the rectangle. So first we add in the surface, and the second the rectangle that we just created. So now if you run it, it's still not showing up. And that's because we are first putting the text on the screen and then placing a background over it. So actually it's there in the game, but it's behind the background. So you need to keep in mind that in what order you are adding the code. So you need to put it after the background so that it gets displayed. Now if you run it, it's coming up. Now if you see, it's in the exact center, but it just seems a little bit off to human eyes because the way it gets displayed due to the gradient. So I just like to keep it 25 pixels above. So I'm just going to modify its y coordinate and subtract 25 pixels from it to make it go a little bit higher. Now, weirdly, it fills in the center when it's actually not in the center. Now, after you're done with the starting text, we will be now proceeding to create the bird itself. For the bird, we will be first defining the surface as usual. We will call it bird surf equals pygame.load bird.png and convert alpha. Now this bird.png is the same as this image. If you have downloaded it, then it's available to you right away. Now one thing to mention is the thing that we are adding here, convert alpha. Now if you notice that our bird.png is a png file. The problem with that is when processing those images, it's a bit difficult for Pygame to actually process PNG images, but it is easier to process it if it has its own format. So convert alpha basically converts the PNG file into Pygame's image format. So due to it, it's able to process it a little bit faster. And there are two methods. One is the convert and another one is convert alpha. Now, if you see, our bird has a transparent background. Now, if we don't use the alpha one, then we will get just a white background. Let me show you in a bit. But before that, we'll be creating the bird rectangle. We will call it bird rect equals bird surf dot get rectangle. It will create a rectangle from the surface directly. So we will define the center position equals giving it a tuple, and the x coordinate is going to be 100. It would be 100 pixels from the left, and for the y coordinate we need it to be in the exact center. So for the y coordinate we can simply add config screen height by 2, that will give the exact center, and as same for the text I will subtract 25 pixels from it to make a bit look in the center but not actually. Now, if you play, obviously the bird is not going to be visible because we have not actually rendered it on the screen. Basically screen.blit. So to show the bird on the screen, we will be adding screen.blit. Another note here, I'm adding the bird after the background because I want the bird to be on the top of the background. So screen.blit, first the bird surface and then the rectangle. Now if we run it, we can see the bird on the screen. Okay, I misspelled this center spelling. And when we run the game, you can see we have a big problem. The bird is too big for the screen. So we need to scale down the bird by a certain factor. Now this can be done while creating the bird surface itself. So Pygame has a method called transform scale by. So using that we can reduce the size of the bird surface itself. So pygame dot transform dot scale by, and in this we will add the bird's image itself, and how much do we want to scale it by. The most appropriate I found was 0.075, that is 7.5% of its actual size, and this method returns a surface itself, so we will convert it to alpha. You don't need to, but it's the best practice that I use because you never forget that you will be adding a raw PNG image itself. To move the bird ahead itself, what we can do is to move the bird, we move the rectangle of the bird, not the surface. So We select the bird rectangle and say that move its center X by 3 pixels. And if we run this, you can see the bird goes ahead. This is the first animation you just made, but it just goes out of the screen. To fix that, we need a certain flag that when the game starts, for a certain amount of loops only, we need the bird to move. So for that, we create a flag called game start equals false. The game has not started yet. But when the game starts, when game start is true, we create a loop in it. For I in range 0 to 50, move the bird rectangle by 3 pixels. Now, the game should only start when we press space. So, to also add that too, we will add an event inside the event loop. So, in the event loop, we check if the space key is pressed. Now, in Pygame has a variable called key equals pygame dot key dot get pressed. Now, this will return all the keys that are pressed during this event loop, and this list would be stored in key. Now to see if the space key was pressed, we type in if key of pygame dot k space, then we set game start equals true. So if I run this now, you can see it doesn't do anything, but this is me pressing space. It went right away, but it did something. Now to fix this, this is a little bit complex, but bear with me, you will understand it what's going on exactly. I need the bird to go just a little bit and the main game should start. In the final game, when I press space, the bird moves a little bit ahead and then the actual game starts. To make the logic of this, I will be creating two different loops. In the first loop, it just waits and checks if the game is starting, and when the space key is pressed, it will start moving the bird itself. But when the bird is moved ahead a certain distance, we need the loop to break. So we say that when you are finished moving the bird, break this while loop. But if I just run this, it just ends because it did move the bird, but it just rendered a single loop. And that's a problem because we are updating the screen right here. While it's in this loop, it doesn't update the screen. So we need it to update the screen. And also use clock.tick to actually time the frames. So once I add this, now if we run this, I'm pressing space now. But now the game exits after a certain time. That's because we are updating the bird, but as soon as we are updating the bird, we are placing the background over it. Now this is because we are moving the bird, but still we are not using screen.blit to update the image on the bird. So we add that too. Screen.blit, the background, because we need to clear the old screen first and then add the bird. Now if we run this and press space, as you can see the bird moved a little bit ahead, but the game stopped. Now I would like to look here that if I comment this background and don't update the background itself and just update the bird, this is going to happen. It doesn't clear the old image of the bird itself. So adding the background, running the game, the bird moves ahead and the game ends because we just exited from the loop. One more thing to note here that as soon as we press space, the text itself goes away because the text is in the outer loop. In the inner loop, when we are moving the bird, we are not updating the text itself. So as soon as we screen.blit background, the text is replaced with the updated background and the bird is only shown, not the text. Now with this, you have created the starting of the game. This starting consists of opening the screen, showing the bird and the instructions to start, pressing space and the bird goes ahead. Now in the final game, when I press space, the bird goes ahead and the pipes are getting displayed. So our next step is to show the pipes itself because those are the main part of the game. Without those, the game doesn't do anything. So after it's done with starting the game, we will be creating another loop where we'll be rendering those pipes. For that, we will be creating another while loop and adding the same thing itself. If exit is or quit or the cross key is passed, it should close the game and we need the clock to make it exactly 60 frames per second or at least 60 processing steps per second if that makes sense. Now before adding anything to this loop, we will first create the pipes itself. Now to create those pipes, I have added two pipes, a pipe B and pipe T for pipe bottom and for pipe top. In the final game, if you see, the bird needs to go between them. And if it's the same image, then it's going to be a straight line and we need to detect a collision between the bird and the pipe. Now, if it's just a single image, then it's going to be a long rectangle. And even if the bird goes from between, it would technically collide with the rectangle of that image. So for that, we need two different rectangles. To explain it a little bit further, let me open Paint for you. These are the two different rectangles, and if the bird center collides with one of these rectangle, then the game should stop. But if it's going to be a single image, then the rectangle would be on the complete vertical axis. So if the bird even goes from the center, it's going to collide with this rectangle side. We don't want that, so we need to create two different images. And to create those two different images and manage their position together, we will be creating a class for it. So we create a class called pipe set. Now in the init function, we will be creating the surface and rectangle of both the pipes. Now, if you're not familiar with Python classes, it's not really that difficult. The declaration is class, the class name, and the init method is like a constructor if you come from Java or C++ background. And to manage the parameters of the class, we use self. So all the parameters would be stored in the self variable itself. And for every function, the self is always the first variable that you need to add. Because whenever you call a function, the self variable is always passed as the first parameter. Whatever you add is passed as the second, third, and fourth, and so on. Now, first we will start by creating the surface and the rectangle for both the pipes. So self dot top surf. I'm just calling it top surface because it is in the pipe class, so it implies that it's a pipe surface. We say pygame dot image dot load pipe t.png for the top pipe. Now, while creating the surface, we also need to scale it because the same thing would happen that happened with the bird. So we say pygame dot transform dot scale by, pass in the image surface, and the most proper scaling I found is zero point 0.2 or 20% of the actual size, and convert alpha. Now we also mentioned the self dot top rect equals self dot top surface dot get rectangle, and here we are trying to set the mid bottom coordinate of the image because the pipe is really long. It's not infinite, but we are just concerned with this position. It doesn't make sense to take any other position because this is the most logical position that is going to be on the screen while calculating the x and y coordinate of the pipe. So I have selected the mid bottom, and for the bottom pipe it's going to be the mid coordinate. So we say that mid bottom equals, for now I'm going to set it 300 by 400. And we also define the bottom rectangle. So we can just copy this and paste it. We say that it's the bottom pipe, and we will keep it a little side of it to show both the pipes. Now the rectangles are inside the pipe class, so we add a getter function to get the rectangle of the pipe class so we can modify the distance and other stuff with it. So we call it get pipe rectangle and self, and we will be returning an array where the first is going to be self.toprect and the second one is going to be the bottom rectangle. Okay, I forgot to rename here, so let's rename to bottom. One too many T's. Bottom, and there you go. Also, we need the mid top, not mid bottom, for the bottom one. And here also it's going to be the bottom surface. And in the second element, we return the bottom rectangle. Now to show you how does the pipe is showing up on the screen, I'm just gonna do screen.blend the pipe. So for the pipe, we need to create a pipe object. So I'm just gonna call it pipe equals pipe set. And screen.blend pipe dot top surface and pipe dot top rectangle. Same goes for screen.blend bottom surface and bottom rectangle. And if you are thinking how is the code guessing it what I'm typing, then it's just an extension called tab9. You can just go to this extension and search for tab9. It's a AI coding buddy, AI autocomplete. If you were thinking how was I autocompleting it that, then this is the extension. But anyways, if I run this game, after the first loop gets completed, it comes to the second loop, and here it shows the pipe. Now as you can see here, it's displaying the pipe. Now if in the main game, if you see, the pipes are coming from the right side and going to the left side, and the position of the pipe is also random. It doesn't stay at the same position every time. So we need to create a logic where the position And to be specific, the y coordinate or the vertical position of the pipes should randomly be generated, and new pipes should be generated and old pipes should be deleted. To create this logic, we are gonna add a pipe queue and render the pipes with the set coordinates for the y-axis and x-axis, and then move the pipes along the x-axis from right to left. Now, before that, and also when the pipe should be generated is it should be generated outside of the screen, and then the pipes would come into the screen. And this should happen on a set timer, because if we create 1,000 pipes ahead of the start and keep moving it, 100,000 pipes is gonna be very difficult for the game to manage, and it would slow down the game. So we need to keep creating the pipes at a set timer of 1 or 2 seconds and delete the pipes as it goes out from the screen. So if you think it's getting a little bit complex, here's the summary for the pipes. The pipes should be exactly on top of each other. The distance between the pipes should be a set distance of pixels. The pipes should move from right to left. The vertical position of the pipes should be random. The pipe should be created outside of the screen and then start moving into the screen. When the pipe exits from the screen, it should get deleted. And at a timer of every 1, 2, or 3 seconds, a new pipe should be created and added to the queue. So let's get started with it. Now for starters, I will be adding another config, and it would define the space between the pipes. So pipe space should be the most perfect space that I found, which is not too big and not too small, is 200 pixels. Now to randomly generate the positions of the pipe on the vertical axis, we will create a random function for it. Now for that, we would be getting two different coordinates, one for the top pipe and one for the bottom pipe. So we define a function called get random or rand coordinate for the top pipe, and the y coordinate, that is the vertical coordinate, should be a random number. Now in the game, if you see the pipes, we can just define a midpoint and subtract the vertical distance of the pipe. So the pipe is kept at an offset from the midpoint and the bottom pipe is kept an offset below the midpoint. If we can just generate a random midpoint, then we can generate the position of the top pipe and the bottom pipe together. We don't need to different random numbers and calculate the distance and do a lot of maths. To keep it simple, we will just defining a midpoint and set the positions of the bottom pipe and the top pipe at a offset. So we would be defining a midpoint and passing it to the function. So right now I'm just gonna pass the variable. Think of it that this midpoint is a randomly generated number. So the y coordinate is going to be midpoint minus the offset. The offset is going to be the space between the two pipes and half of that because it's a midpoint. So I'm gonna fetch config of pipe space and divide it by 2. Now x coordinate is going to be fixed when it's generated and we want to move that. We just need the y coordinate to be random. So we return this position of this newly generated pipe as we would be returning a tuple. We set the x coordinate of pipe. It should be outside the screen when it's generated. We don't want it to just pop up on our screen when the pipe is generated. So we define as config of screen width. So we have the width of the screen, and we are gonna add 300 pixels to it. The screen width is 800 pixels, but if we add 300 to it, the position is going to be outside the frame. Now, if it's outside, pygame doesn't really care, but it's good for our logic. And for the y coordinate, we just add a randomly generated coordinate. Now, do remember our midpoint is random. This is just some simple maths. We would be creating a random midpoint in a separate function. For now, we define this function for the bottom pipe too, to get the bottom pipe coordinates. So just replacing the top with bottom, just doing some simple copy paste. And for the top pipe, it was minus the offset, so it would go up. For the bottom pipe, we need it to go down, so plus. That's the only logic. Now we will be creating a randomly generated midpoint. So we create a function for it and call it get random coordinate, or for short randCor. Pass in the self variable and enter a random seed. To make a game a little bit random, it's better to add a seed and set it to its current time. So every time the time is going to be different. If you keep running the game again and again, at a point it sometimes happens that the same series of random number is getting generated. So it's better to add a seed to generate new list of random numbers and add the seed as time.time. This will get the epoch of the current time, and this would create a different list of random numbers every time you run the game. Now you need to define the midpoint equals random.randint, and we define from what range to what range do we want a random number to be. Now do keep in mind that our screen width and screen height is 800 and 600, but right now we are concerned with just the height for 600 pixels. Now in the game, if you see, the distance between the pipe or the mid space is somewhere around the center. We don't want the mid space to go like really above or really low. So we add a padding config to it, and what this will do in our calculation is keep the mid distance a little bit far from the edges of the frame. Pipe gap for the center gap and its padding. And we wanted 200 pixels from above and 200 pixels from below to be away from the edge of the frames. So the randomly generated number is going to be config of pipe gap padding by 10, and the upper limit we want it to be config of screen height minus config of pipe gap padding by 10, and we want to multiply it with 10. Now just missed a few brackets here. This should be here and another bracket here. Actually, I would like to keep it outside the random. So if you don't understand what this does is, then don't really think that about much, but it's basically on the vertical axis, we want it to be a little bit farther from the edges and a little bit farther from the below. So that's why we are giving it a padding limit and subtracting the padding from it. And I'm multiplying it with 10 to create those good multiples of 10, so it just doesn't fluctuate between very few small pixels that it isn't even being able to notice. It doesn't really matter if you subtract 10 and multiply it by 10, but it just feels a bit more natural. After generating this midpoint, we are gonna return a object where the top coordinate is going to be stored in a top key, and that's going to be self dot get random coordinate for the top pipe. We are gonna pass in the midpoint that we just created and add in the bottom pipe and call the bottom random coordinate and pass in the midpoint. A comma here, and with this we can generate random positions for our pipes. Now we did create a random positions, but we need to assign it to those pipes. So our mid bottom is going to be the coordinate of the bottom pipe and our top is going to be the coordinate of the top pipe. So first we get the random coordinates. We can call it self dot pipe coordinates, or you can simply just call it pipe core equals self dot get random coordinates, call it, and now in this variable we have our both coordinates of our pipes. So we can just assign these coordinates to our mid bottom and mid top. So our mid bottom is going to be the coordinates of the top pipe. We have those coordinates in our variable, so we just use those coordinates self dot pipe core of top. That is the top key that we just assigned to it. And similarly, we would have it the same thing for the bottom one. Now, if we run this, the pipes are not getting displayed because currently they are out of the screen. If you want it to get displayed, then you can simply subtract from 300 in both of these, run the game, and the pipes just pop up. We don't want this to happen, so we are creating the pipes outside the screen. But if you keep running the game, you can see that the pipes are not in the exact position. It seems it is, but it's actually generating different positions and it's a little bit up and down from the before. So the pipes are getting generated randomly now. So let me just revert it to plus 300 to keep it outside of the screen. After this, we need to define a pipe queue. And in this pipe queue, we will be adding all our generated pipes. We can just call it pipe queue equals. We'll be using a list to make it behave like a queue. Now we want to add a new pipe inside the queue at a certain interval. For that, we need to create a timer in pygame. So to create a timer, the logic goes something like this. We just create a event variable and we'll call it create event equals pygame dot user event plus 1. Now in pygame we can create a lot of different number of events and test it if the event was executed. I'm just creating a variable called create event which would detect a certain action. Now after that I create a timer in pygame. It's called as pygame.time.setTimer, and whenever this timer gets called, create event would be assigned and we would be calling it at every 1000 milliseconds or 1 second. Now when we execute this timer and it gets activated, now if you are thinking that what if two of those are exited and only one is deleted? Now that won't be the case because our pipes are being created one in 1 second, and in 1 second we are checking for this condition 60 times. So probably that's not going to be the case. Now if I run the game to just check it works, The pipe goes out of the screen. Obviously, we can see it. It gets deleted, but it's getting deleted. Next thing we need to add is the collision detection, that if the bird collides with the pipe, then the game should stop, or at least show some message that it's game over. Now to find collisions, we will be creating a function called did collide, which will be basically checking if the bird collided with the pipe or not. So in every loop, we just check for a if condition did collide. Now we will need to define this function and create its behavior. But for now, I'm just going to pass in the pipe queue to make sure that each and every pipe is checked if the bird collides with it or not. And we are going to pass the bird rectangle itself. Now using the pipes rectangle and bird's rectangle, we are going to check if it collides or not. So before creating the if statement, first will be creating the function. So we can define it somewhere above here. And in this, we are taking our pipe queue and our bird rectangle. Now here also we'll be creating a loop that for every pipe in pipe queue, check that if bird.rect dot, now we will be using a inbuilt collision detection function given by pygame. It's basically the rectangle dot collide rect and pass in which rectangle it collides with. So we are gonna check that for every pipe, so pipe dot top rect, and we will be also checking for the bottom rect. So once for the top rect, if it collides with it or if the bird collides with the bottom rectangle, we would return true, else we will return false. Now do remember, now a quick coding tip, never use else statements. Else statements are really bad for your code. If the function does only one thing, checking a condition, then you just need a single if statement, and if nothing works out, just return false at the end of the statement. This would help reducing the loops and preventing your code from defects. So that's why I'm not using a else statement here. Now, when checking the collision, we are gonna say if did collide, then we need to stop the game right there. So first, I'm gonna screen.blit, and in this I will be displaying a endgame text. In the final game, if the bird collides with the rectangle or pipe for say a message is displayed game over, please press space to start again. So we will be creating a text for that. Now as we created for the start text, we will be creating the same for the end text. So we will simply call it as end game text surf, end game text. Okay, I have just misspelled it here. It should not be test but text. So I will just replace it. And now it's better. So endgame text surf, and the message it would be displaying is game end, a few exclamation marks, press space to start again, and that's it. Now we want this to be also in a similar position of where the start game text was. Now, if you see here, I'm using the same font object to create both of those text. For a single font type, you just need one object and with it you can create multiple text. Now we will use this text. So screen.split end game text surf. First goes the surface and end game text rectangle. Now I guess I have misspelled this too. So it should be text. Now if you run the game, we will just wait for the bird to collide with some rectangle. Now if you just see, it did appear for a split second, but we want the game to stop right away. It should not go ahead because it does check for a collision. It shows the message, but it just goes ahead and it says, okay, nothing happened. So what we want to do is first display the message. Then we are going to say pygame dot display dot update to update the screen itself. And after that, till the user doesn't press any key, it should not start, and essentially the space key. So it should get stuck somewhere around here so the code doesn't go ahead. So we will create a while loop for this. Now this while loop is going to be very similar what we did before. It will be just checking for an event, and if quit, then it should get quit. And in this we will check if the space key was pressed. So as we did before, we first find whatever the key was pressed, the list of the key for say pygame.key.get. This it's get pressed. This will fetch the list of the key that were pressed. If key of pygame.k space, that is the space key, we are gonna screen.split the background. Now we also want to clear the queue that we had for our pipe because the game technically should reset after this, so we also clear out all the variables. So pipe queue equals a new list. We reset the position of our bird. We set it as 100, the x coordinate, which is exactly the same position that we defined it in the starting, and also reset the y coordinate. Now right now the bird doesn't go up and down, but if it goes, we need to reset its coordinate too. So it would be center y equals, we want to pull it to the center of the screen. So we say config of screen height. Now as you can see, we can just access the config variable. If we are going to change the size of the screen, it would scale and make sure stuff doesn't go wrong. That's why we did create a config variable. We are just subtract by 2 and minus 25 to make it at the center. Now when the k space key is pressed, that is the space key, it should break this loop and continue with this loop. So for that we'll be creating a flag because it's inside a loop and we want to exit the loop outside. So we define a variable called reset equals false because it should not do anything until we press the key. So reset equals false, and when the k space key is pressed, we say reset equals true. Now in this inner while loop, we check that if reset equals true, then it should break the loop. And in here, we also need to define the timer function, that is clock.tick, because it's constantly executing the inner function, but we don't want it to run at 1000 frames per second or whatever our computer can manage. Now we are not updating the screen here, we are just waiting, so I have not used display.update inside this loop because we just simply don't need it, but we do need the timer. Now if we run the game and wait for the bird to collide with a rectangle, the message is displayed and okay, I think we got an error here. This should be two different parameters. Forgot a comma right there. Now if I play the game and the bird collides with the rectangle, the message is displayed, I press space and the game starts again. Now one problem is the bird doesn't really move above or below. We need to animate that too. Now in the actual game, the bird goes down if you don't click any key, and if you press a key, it should fly above or go upside. Now to simulate that, at every frame, we are just gonna add a value to the Y position of a bird so that it feels like the bird is going down if we don't press a key. So we are gonna say bird rectangle dot center Y plus equals, let's try 10. So we start the game, the bird is going way fast. Let's try maybe 3. Now this feels a bit more like it. Now if we press space key, then it should go up. First we get whatever the keys were pressed, pygame.key.getPressed, and if key of pygame.kspace, then we want to increase the y coordinate or rather decrease the y coordinate for the bird to go up. So we say that bird direct center y minus equals, let's try with 3. Now the bird goes down, but I'm pressing space, but it's still way fast. So I need to increase it a little bit more, let's say 7. Now if I press space, you can see here a game technically works, but it still feels a bit weird because what we just did is linear gravity. Now the problem is we are adding the falling effect in a linear fashion. We are just adding 3 at each frame. But in real world, falling objects don't catch speed linearly, but rather exponentially because gravity is an acceleration component. So to simulate more natural, to simulate more natural gravity, we normally use a technique where we try to simulate gravity, but we don't care about actual physics, the way it's used in 3D games, but we try to simulate it just to make it feel if it's real. So we do that by gravity equals 0, and each frame the gravity is gradually going to increase. So for each frame, I'm just gonna increase the gravity. Now these are just numbers that I have found to be feel more natural. You can play around with them, try different numbers, but this is what I got the best results with. So at every frame, I'm gonna increase the gravity by 1.5. Now after incrementing the gravity, we add that gravity to our bird rectangle y coordinate. So gravity, and I do this by 7. is just calibration stuff to make it feel a bit more natural. Now, if I run this, you can see that the bird falls in a incremental rate. Let me run it again. If you can see, the bird starts slowly and then increments really fast. Now, if I run the game, there is one problem. If I press space, even how many times I press space, it's not going to work because we are incrementing the gravity, and after certain frames, it's going to be so high that it would basically make the game impossible to play. So when the space key is pressed, we also need to reset the gravity to 0. Now if I run this game, it looks like our gravity is working, and it's a little bit different than the linear gravity. Now in the final game, the bird also rotates upside and downside because I guess that's how birds fly in real life. So to add a rotational component to a bird, we will create a variable called bird ROT for rotation, and right now we'll set it to 0. While rendering the bird, we want to rotate this bird according to our variable. So while displaying the bird, we pass our rectangle to a transform function pygame.transform.rotate. This is going to rotate the surface, but with this we also pass in the rotational component, that is the bird ROT for rotation. Now to actually rotate the bird, we say that if bird rotation is greater than minus 20 degree, then bird rotation should subtract by 1. Now this will basically make the bird fall downside. But when we press the space key, the bird should go on the upside. So we add that logic here too. That if bird rotation is less than 25 degrees, then we just add bird rotation and increment by 20. Now if we run the game, you can see that our bird is going down, and when we press space, it goes up. Now we are right towards the end of our tutorial. There is just one thing left to make our game final. If we let the bird go down, it just goes down and the game doesn't end. So if the bird touches our borders, the top and the bottom one, then the game should end too. So we do this in our collision logic too, because we also want to check that if it collides with the upper edge or the downer edge. So we also add another if condition, that if, see that you add in the same hierarchy of for, make sure you don't add it inside the for loop. Bird rectangle dot center y, if it's greater than config of screen height, that is if goes beyond the screen height, or we want to check the same thing for the top, because if we keep pressing space, the bird could also go on the top edge. So we just say bird rect dot center y, if it's less than 0, that is the top edge, then it should also return true. Now if we run the game, if the bird falls down, the game ends, and if the bird goes up, it game ends too. Now right now I'm just keep pressing space, so the game's got restart, but yeah, if the bird goes above, it resets too. And with that, you have finally created your own RaPyBird game. And with that, we come to the end of our tutorial. We created a RaPyBird game in 155 lines, minus a few spaces here and there. If this was your first time created the game, then I hope you enjoyed creating the game. If you did stay and go through the entire tutorial, then I guess you liked my video. The next video I will be creating would be a snakes game in Python using the same pygame. I have also created a tutorial for Snakes game in C with graphics library of C. You can check that out or you can wait for one in Python too. So thank you for watching this video. If you like this video, then give a thumbs up. Subscribe to my channel. The next video is going to be Snakes in Pygame. If you want to check out that video, then don't forget to subscribe. If you face any difficulties, if something is not working out for you, you can always look up my code in my GitHub repository. It would be in my description. If still you face some error, you can definitely mention in the comments. I will be most probably helping you out there. So I guess that's it. See you in another video. Thank you.